Hello guys, today we're going to continue the great work we started on quadratic equation and expression. Now don't forget the fact that quadratic equation and expression is simply one of the major equations under advanced algebra. In our previous lesson, we used factorization method, so we perfected everything in that. So today we're going to be using what we call the completing the square method. Completing the square method. Now when you look at this very method, square, when we talk about a square, what's a square? A square is one of the major quadrilaterals that we have. When you look at a square, all the sides are the same thing. A square has equal sides. So if this is 5 centimeter, we have 5, we have 5, we have 5 all through. So how do we connect this very stuff with quadratic equation? Now, why do we call it completing the square method? Now, this very method helps us to transform or to regenerate a given quadratic equation into something with identical roots. Now, that's what I mean. If the roots of a quadratic equation are identical, let me say the root of this is 5 twice. That is x is equal to 5 and x is equal to 5. What does it mean? It means when you send this over, x minus 5, x minus 5. Now when you expand this, what do we have? This x squared minus 5x minus 5x plus 25. You have x squared minus 10x plus 25. So when you look at this very quadratic equation that we have here, don't forget it has said that the first thing we have to look out for before we even start solving the quadratic equation is to check if that very equation is indeed a quadratic equation. How do we get to know a quadratic equation? A quadratic equation has the highest power on is unknown to be plus 2. So this is a quadratic equation for sure. There's no doubt about that. So this, when you look at this right here, we have the same root, 5 and 5. It's just like a square that has the same length of side. So a square, let's say 5 centimeter, 5 centimeter. So we can relate this with a square. So I mean a square. So when you look at this, the roots are the same. We have 5 twice. So this is a perfect square. This is a perfect root. This very quadratic equation has identical root. So the work of this very method is to look for a way to convert or to transform any given equation with unknown root. I beg your pardon, with roots that are not identical. It helps us transform them into something that has perfect root in a way. So for example, if we have x squared minus 3, for example, now and look at this, x squared minus 3, x squared minus 3x, let's say x squared minus 3x. Now, this very method could help us transform this very quadratic expression, because there's no equals to here, that's a quadratic expression. It could help us transform this into something that has identical roots. Now, how do we achieve that? The only way we can achieve that is by using this, there's something we call discriminant, b squared minus 4ac. We're going to see this in our next lesson or exposition when it's time to use what we call the formula method. So if we call it almighty formula. So we're going to see this. Now, this is called discriminant. Now, this helps us to test if a given equation is, it tells us, it tells if a given equation has identical root, or if a given equation has, a given root but not identical root, or if a given equation has roots that we call complex numbers. So that's the work of this discriminant. This is called discriminant. So for identical roots, a discriminant is equal to 0 for identical roots. So if a discriminant is equal to 0, it means b squared minus 4ac will give us 0. When we send this to the other side, it's b squared equal to 4ac. So when we keep working on it, if a is equals to 1, it means we end up having c, have a b squared equal to 4c, divide both sides by 4. Then c is b squared over 4. C is b over 2 raised to power 2. So that's the formula we use for us to get what we're going to add to this. That's this x squared minus 3x. We have to look for a way to add something to it to make it become, a perfect root equation, a perfect root expression, quadratic expression. So we've added k to e. Now the k is represented by c. A is 1, b is 3, then the k is the c we are talking about. So what's going to be the value of k? The value of k, which is the c which we are looking for, is b, which is minus 3 over 2 raised to power 2. So we'll work on this. That minus 3 over 2 times minus 3 over 2 will give us 9 over 4. So we're going to have 9 over 4 today. That is s squared minus 3s plus 9 over 4. So how do we factorize this? How do we work on this? Don't forget the product is positive. If the product is positive, it means the roots have the same signs. It means the root have either plus plus or minus minus. So what do we have in the sum? The sum is minus. It means the roots are both minus, minus, minus. So 9 over 4 is 3 over 2. That's 3 over 2 here, 3 over 2. As you can see, this very stuff has been transformed. And don't forget, plus 9 over 4, we are the one that introduced plus 9 over 4. So we had our minus 9 over 4 to this place to make it remain the way it was. So when you expand, you get this. So s squared plus minus s squared minus 3s plus 9 over 4 minus 9 over 4 will give us s squared minus 3s. Now this is just what this method is all about. This is not the main question. We're going to move into the main set of questions now. So don't forget, this method helps us transform a given quadratic equation that has potentially unequal roots. It has to transform them into what has equal roots. That's what we call it completing the square method. Okay, right here we have the first worked example. Now we have to solve for x in minus 4x squared minus 6x plus 15 equals to 0. Now this is quadratic. As you can see, the highest power we have here is plus 2. This quadratic. That's the first thing we have to watch out for. Don't forget, very important. Now, apart from the fact that this quadratic, this is not just quadratic. This is a quadratic equation. We have the presence of an equality sign. It means there's a balance between this very side and this very side. Now, as you can see, the very one, the unknown with the highest power, that's s squared, has a coefficient of minus 4. So now we can do it in a different way. Since this is equal to 0, I can decide to send this 2 to the other side. So that will give us 4s squared plus 4s squared plus 6x equals to 15 here. That's the first thing. Now don't forget this A, this B, and this is C. Now we're going to be using the completing the square method. At least we've seen a glimpse of what this very method looks like. So now the next thing we're going to do now is we're going to use the coefficient of the unknown with the highest power. We're going to use the coefficient of the unknown with the highest power to divide all through. So that's plus 4 right here. So it's going to be plus 4 divides this, and divides this. So what I'm trying to do, I'm trying to look for a way to transform this very remaining piece into what will have the same root or identical root. So 4 is divided all through. So what do we have? This s squared plus 6x over 4 equals to 15 over 4. That's what we have. So what do we do next? The next thing we're going to do is we're going to look for a way. Don't forget, this is still quadratic. This is still quadratic, but it's no more complete. The C part has been sent to this place. We have a C part here. Now, for the part that we have the C part here, what does it mean? We have to look for a way to add something to this place that will make it become complete again. So what do we do now? The s squared plus 6x over 4 plus k equals to 15 over 4. Now, don't forget, whatever you do to this place, you have to do it to this place also in order for this to remain an equation. If not, it's not going to be an equation anymore. So k has been added. So we're going to do the same thing here, plus k also. Now, how do we know what the value of k is? Don't forget, this is A. A now is 1. B is C over 4. And then C is k. S is power 2, S is power 1, S is power 0. I can say 2 here 3, 2 here 2. So the A is 1. The B is 3 over 2, while the C is k. Now, don't forget, the formula was right. The C, how do we get the value of C? Is B divided by 2 raised to power 2. Now, this formula is only possible when the A is 1. Now, if the A is not 1, you have to look for a way to get rid of the A. Just like what we did here. The first thing we did was after we sent this 2 to the other side, we got rid of the A by using the A to divide all through. So we end up with a stuff with an unknown with a coefficient of 1. So after you've done that, then we get the value of C. What's the value of C? C is 3 over 2, that's B, divided by 2 raised to power 2. So that's 3 over 2 divided by 2 is 3 over 4 raised to power 2. This is what we're going to add to both sides. That's the value of C. That's the value of K. The C is the K, don't forget. The C is the K we are looking for. So, s squared plus 3x over 2 plus 3 over 4 raised to power 2 equals to 15 over 4 plus 3 over 4 raised to power 2. So what do we do next? Now it's high time we got this factorized. Now out of the factorized, we look at the product. The product we have here is positive. Whenever the product is positive, what does it mean? It means root with identical signs, came together to form that very product. So for the fact that I have a positive, we have a positive product, it means we have either minus minus or plus plus. Now let's see what the sum has to tell us. The sum says the signs are identical or positive signs. You understand? So the sum is positive. It means the roots have the same identical signs, which are plus plus. So this I have a plus, I have a plus here. So what I have here, 3 over 4 raised by 2. I'll just share it out to both sides. 3 over 4, 3 over 4. Completing the square method as an achieve. Now we have a kind of quadratic, I can call this expression probably when you took up the equals to, but we have some stuff on the other side. We have an expression here with the same root, and that is the reason we call the square, completing the square method. So we have this already, equals to 15 over 4 plus 3 over 4 raised by 2 is 3 over 4 times 3 over 4, which is 9 over 16. So here we're going to pick 1. That's x plus 3 over 4 raised to power 2 equals to LCM of 4 and 16 is 16. 16 times 15 over 4. 4 over 1.16 is 4. 4 times 15 is 60. 16 times 9 over 6. 16 times 9 over 16. We divide 16 divided by 16 is 9. We have that already set out. So what do we have? We have s plus 3 over 4 raised to power 2 equals to 69 over 16. So look for a way to get rid of the power here. We have raised to power 2. How do we get rid of the square? We multiply it by its multiplicative inverse. So 1 over 2 times 1 over 2. So 2 takes out 2. We have just s plus 3 over 4. So I'm going to bring it up here. We bring it up to this place. So what do we do next? You take this to the other side. Take it up. So that's s plus 3 over 4 equals 2. Now 69 over 16 raised by 1 over 2. Now whenever you get the square root, don't forget that whenever you get the even root of any stuff, it's going to be plus or minus. We said that before in our previous lesson. So this 2 here is going to be the square root of 69 over 16. That's s plus 3 over 4 equals the square root of 69 over 16. What's it going to be to the plus or minus? Anytime you're asked to get even root, square root, fourth root, sixth root, and so on and so forth, you end up with plus or minus. So we send this to the other side. That's f equals to minus 3 over 4 plus or minus square root of 69 over square root of 16. So what do we do next? We're very close to getting the result or value for x. We're not far from it. Almost got our values for our root for x. So the x equals to minus 3 over 4 plus or minus square root of 69 is 13 over square root of 16 is 4. So what do we do next? Now the minus 3 plus 13 over 4, or let's just do this. That's minus 3. You can see the bases are the same. So what do we have? We have minus 3 plus or minus 13 over 4. The simple mathematics. So what do we do next? Minus 3 plus 13 over 4, or minus 3 minus 13 over 4. Don't forget the plus or minus was gotten after we put this, after we got the square root of 69 over 16. Any even root gives you plus or minus. You understand? So we're almost there. We're done already. Minus 3 plus 10 will give us 10 over 4. Minus 3 minus 13 will give us minus 16 over 4. 2 here 5, 2 here 2, 4 here 1, 4 here 4. So the value of our x, the root of our x, the root of our x is equal to 5 over 2 or minus 4. Now even from here we can factorize. We can use this method to factorize. It's very simple. Just send this over here, and we are done. As simple as that. So these are the roots of the very given quadratic equation we are given using the completing the square method. So I'd love you to stay tuned, and I'd love to stay tuned actually for more questions on this, for more worked examples. So see you in the next lesson. Thanks.